Algebra 2 Honors 3.4a notes. And so we're going to be developing the quadratic formula, and we're going to solve equations using the quadratic formula. And when we derive the quadratic formula, we are going to use that process of completing the square. And to complete the square, we need the coefficient of x squared to be 1. So we are going to take this quadratic equation and move the constant to the other side. But I need the coefficient of x squared to be 1, so we're going to divide by a. Leaving space to complete the square, but we have to divide both sides by a. So on the other side, we have this minus c divided by a. And then remember when you had just an x squared plus bx, that to complete the square, you took half of that coefficient of x and you squared it? That only worked if the coefficient of x was 1, for it to just be b divided by 2. We're still going to find the same pattern, it's just that the coefficient of x isn't just b. So the coefficient of x, we've got it where now x squared has a coefficient of 1, but the coefficient of x is b over a, so to complete the square, I need to take b divided by a all over 2 and square. And that is b divided by a divided by 2 squared, which is b over a times 1 over 2 squared. So what you have is b over 2a quantity squared. So this is just, working with fractions. That's abstract because we have variables, but when you take half the coefficient of x, which it probably would have been just easier to half the coefficient of x and square it, you're going to be squaring this quantity b over 2a. So just making use of structure to see that a couple different ways. And remember that this was when we had just a coefficient of x that was b, but now our coefficient of x is b over a. So you need to take half of it and square it. So now when you square that, you square all of those values inside. So it's b squared over 4a squared. And that is squaring and completing the square. So now I have to add that to both sides to keep it balanced. And okay, I kind of just jumped into solving this, but the great thing about the quadratic formula is I don't have to rely on factoring, and some things don't factor, so this is going to be able to help me find solutions to the ax squared plus bx plus c equals 0. We're developing a formula so that we can go right to the formula rather than doing all these steps every time. And so continuing with, we have now a perfect square trinomial that factors into x, and then it is what half of that coefficient of x was, which was the b over 2a, and it is that quantity squared. So it's what was inside here is what this ends up being. And then on the right-hand side, we're going to get a common denominator. And so I'm going to expand this, and to get a common denominator, then I'm going to end up, I need the denominator to be 4a squared, so I need to multiply both the top and the bottom by 4a so that I can have a denominator here of 4a squared. All right, so now I have this, I'm going to write it x plus, I'm going to just copy this one more time here because I want to put that right-hand side, it's all over 4a squared. And I've got a negative c plus b squared. Oh, except for, excuse me, I need to go back up. I messed that up. I got so focused on the denominator. Hopefully you're catching. I need this to be a minus 4ac. Almost missed that one, sorry. You're probably wondering what I did there. So anyway, so you multiply both the top and the bottom by 4a, produces that to be a minus 4ac over 4a squared. So now that I have a common denominator, I'm going to write that positive term b squared first and the subtraction of 4ac second. That I have that common denominator. And then take the square root of both sides. And when I do that, I get plus or minus the square root of this b squared minus 4ac all over 4a squared. And so on that right-hand side, I can think of that as the square root of b squared minus 4ac, and that's as simple as that gets. You cannot simplify that. But in the denominator, the square root of 4a squared, those are perfect squares. 4 and a squared are perfect squares, so we're going to have 2a. And then I'm just going to come up here. I am going to subtract the b over 2a from both sides. I'm going to put it in front. And so x, they have common denominators. So I'm going to put the opposite of b plus or minus the square root of b squared minus 4ac. And that gives you an expression in terms of a, b, and c that if you plug in the values a, b, and c into it, it gives you that x value that will make that 0. It gives you the x value that will be the root, the solution. And that is the quadratic formula. So now we can go right to this formula directly and plug in the values of a, b, and c. You'll notice that that is the formula that they have right down here. If you have ax squared plus bx plus c equal to 0, the solutions of the quadratic equation is x equals a negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's what we're going to do to solve. So the first thing in example 1 I'm going to do is get it set equal to 0. I like to keep my x term positive, so I'm going to just subtract 10 over. And then identify a is 3, b is 4, and c is a negative 10, just so that I can plug those in. And so the formula says it is x equals, and you need the x equals. We're finding the roots, the zeros, the solutions to this, and so they are x values that are going to make this equation true. The opposite of b, which is a negative 4, plus or minus the square root of b squared, and b is 4, so if I square b, right, I'm going to get 16. And then minus 4 times the value of a times the value of c. So I need to extend my radical, put my fraction bar. So that so far is the negative b plus or minus the square root of the b value squared minus 4 times a times c, and then all over 2 times a, all over that 2 times 3. So we have a negative 4 plus or minus the square root, and then you need to evaluate that. We've got a negative times negative is positive, 4 times 3 is 12 times 10 is 120, 120 plus 16 is 136. All over 2 times 3 is 6. Now don't start simplifying. You cannot simplify the 4 and the 6 and make it 2/3 because we have addition in the numerator and you need to be able to take out a 2 from both terms in order to simplify. So we need to work on simplifying the square root of 136. I don't know what the largest perfect square of that is. And just remember, you should not be using your calculator to simplify that. You need to know how to do this without using a calculator. So anyways, 2 is the smallest prime number that goes in there. And it goes into 13 6 times, and then into 16 8 times. So I'm just doing longhand division in my head, basically. 2 goes into 68 34 times, and then you get a 2 times a 17. And so for me, for every pair, you bring one outside. So this is saying that the square root of 136 is equivalent to, for the pair of 2's, I bring one outside. And anything that any numbers that are singletons, the 2 and 17 are singletons, you multiply and put back underneath the radical. So the square root of 136, the largest perfect square that went in there was 4, which I wouldn't have known that to begin with, but it is. So I get negative 4 plus or minus 2 square roots of 34 all over 6. And now, in the numerator, both terms have a 2. If I factor that out, so if I factor out that 2, then I have this negative 2 plus or minus the square root of 34, and that's all over 6. And now I can reduce that 2 and that 6 and make that a 3. Just be careful not to try to simplify. The 2 had to be in both of these two terms, the 4 and the 2 root 34, in order to factor it out and reduce it. So my final answer is x is a negative 2 plus or minus the square root of 34 all over 3. And we could break that into two values. It could be x is a minus 2 plus root 34 all over 3, or x equals a minus 2 minus root 34 all over 3. And then we could put each of those into a calculator if we needed a decimal approximation. All right, so just need to practice these some more. So maybe you want to, turn the video off and try this on your own and then see if you did it correctly. It would be a good time for you try it. If you're not feeling quite ready yet, maybe watch me do example 2 and then certainly try it for example 3. So, okay, let's see how you did. We have a 4x squared. I am going to move everything to one side, so I'm going to add 13x. Add the 16, set it equal to 0. And in this one, this is an equation. It's okay to divide both sides by 4. Since 4, 16, 16 all are divisible by 4, that will make this a little easier to work with. But it's because you have two sides of an equation, I'm dividing both by 4, and 0 divided by 4 is just 0. These will have the same solutions. These will have the same solutions. And so then my A value is 1, my B value is 4, and my C value is 4. And it said using the quadratic formula, so you need to show use of the quadratic formula. So we get x is a negative b, the opposite of b, plus or minus the square root of b squared, which 4 squared is 16, minus 4 times the value of a times the value of c, all over 2 times a. And so I get a negative 4 plus or minus, and you get 16 minus 16, which is the square root of 0 over 2. And so that, in this case, the square root of 0 is 0, and you just get a negative 4 over 2, so x is a negative 2. Well, in this case, it just simplified to that value. How'd you do? Again, pause, try 3 on your own, and then check and see how you did. All right, let's check and see how you did. 5x squared plus 2x plus 1 equals 0. My A value is 5, my B value is 2, and my C value is 1. So I'm going to plug into the quadratic. The opposite of B is a negative 2, plus or minus the square root of B squared is 4. 2 squared is 4. Minus 4 times the A value times the C value, all over 2 times A. And again, don't do things like think that those 2's could cancel. You can't. You have to have a value of 2 or something that's factorable by 2 in front of the square root in order to reduce that. You can't cancel out those 2's. And you can't cancel out something under the radical, such as the 5, with in the denominator a 5 that isn't underneath that radical at all, that you can't simplify those either. So we get a negative 2 plus or minus, and we get 4 minus 20, which is the square root of a negative 16, all over 10. Again, even though 2, 16, and 10 are even numbers, the 16's under a radical. You cannot simplify that right there. Now the square root of 16 is 4, and since it's negative underneath there, it's imaginary. So we get negative 2 plus or minus 4i all over 10. Now, you're going to need to, when it's imaginary, always write them in standard form, which is a plus bi. And so this is a negative 2 over 10 plus or minus, I'm going to write it 4/10 and a flat fraction with the I off to the side. And each of those reduce, so you need to reduce them. And you need to split them up and put them in standard form, a plus bi. It's expected. And so there are extra problems in the book and examples that you could try. You can, so if you need more practice, reach out, because there's a lot of problems. You can probably look up solving equations using the quadratic formula worksheets and solutions and have plenty of problems to practice in order to become proficient. Please make sure that you don't lose communication points. When you don't put the x equal and you do something like this, you're going to see on the test -1 or maybe more points for communication. So make sure you're following the structure that I'm doing. This needs to be an x equals. And you don't have to put the x on all of them, but when you get done, yeah, it's an x equals. So make sure you're making use of structure, working down the page just as I showed.